So my name is Nino Bice. I'm product manager for an AWS service called Amazon Comprehend. And today I'll be joined by Ben Snively, one of our principal service architects on the AWS team. And we also have a special guest. We have a customer joining us on stage from Chick-fil-A. So we'll introduce them later. So let's dive in here. I know we're a little bit behind. So the purpose of this talk is, not to really go deep on NLP. We're happy to talk about that after in a Q&A format. I will show you a little bit of the service itself for those folks that are new to NLP. But what we really want to do in this talk is show you what to do with NLP, right? Natural language processing. So Amazon Comprehend itself is a continuously trained natural language processing service. So what that means is, behind the service itself is a rather large team of data scientists that are continually collecting information, retraining these models to increase accuracy and coverage of the concepts and the accuracy of which they extract these concepts from text. The team also has a fairly large, awesome engineering team that's running it. So the service is very performant, very scalable. So those things to us all manifest into a continuously trained NLP service. I always like to joke that, if you're thinking about taking on a natural language processing project yourself, that's great. You should do it. There's a lot of really nice libraries out there. But if you really just want an API that has it for you, is continuously learning and getting better over time, then we think Comprehend's a really good fit for you, or the right value prop. So that being said, we want to talk a little bit about, we've gotten some feedback. Folks say, I'm still kind of new. I want to understand, what do I do with this? What do I do with Comprehend? So we see from customers these three big opportunity areas. News media. So we have a lot of customers in the ad marketing tech space that are making sense of news media content. So what I mean by that is they're analyzing news. They might be looking for news that mentions their brand or product. They might be looking for news that mentions a competitor. So they have a continuously running service looking for these concepts. They might be looking for something that mentions their brand, product, or even their competitor's brand or product in a negative or positive way, right? So you can imagine these scalable sort of, almost like semantic real language monitoring services that we see a lot of these patterns emerging. So you can do things like, remarket really positive content about your company, or go address issues where it's negative. Customer engagement is another key area for us. So we see a lot of our customers using Amazon Comprehend to understand what their customers are saying and how they're feeling about their brand, service, or product. So this could be anything from call center conversations. If you guys know, we have Amazon Transcribe, which is a speech-to-text transcription service. So stitching these services together, you can now not only capture the call, you can analyze the call, and then you could even build really cool dashboards that let you know, like, there's an issue going on right now, almost in near real time. And one of the demos that Ben will show you is how he does that with using Elasticsearch. Social media analytics is another key thing. This is kind of something that's, I would say, has been more the mature space here. What that really means is, hey, our customers are talking to us, our services, our products, they're talking to us through Twitter, they're talking to us through Facebook, they're talking to us, in online comment forums. And Amazon Comprehend is a great way to automatically monitor that, to look for things you want to know, understand the trends, what people are saying. And then, of course, the last thing we think about is, I always like to say Amazon Comprehend is great for analyzing text. It's also an information organization service. So, we have something called the Topic Modeling API. And with this API, you can actually go in and organize information. So let's say you have 5,000 documents, which each one uniquely represents customer feedback or maybe a call center conversation. You can easily organize all of that content into the terms that are mentioned within the text itself. It's an algorithm called latent derelict allocation. But so this service we like to think of is, you can come in, you can analyze, and you can organize, and then sometimes those actually feed into each other. It's more of a cyclical process. Those are sort of the key areas we like to talk about. The service itself, just from a feature perspective, comes in the following APIs. We have a sentiment API. These are all RESTful APIs, really easy to use. I'll show you a little bit more detail. We provide a named entity recognition API. That API goes through and looks for proper nouns, categorizes them. So, for example, Amazon would be an organization. We have a key phrase API, which looks for things I say is common nouns, even common noun phrases. We have a language identification API. So let's say your company does business in multiple languages and you got customer feedback coming in and you want to route it maybe to the right team. It will identify the language in the document itself. We have a topic modeling API, as I just mentioned. This API organizes information based on the term frequency of the words in the document. And then we actually just a couple weeks ago introduced syntax API. So this API allows you to actually parse out text into its word boundaries or tokens. So it gets punctuation as well. And for every one of those, it associates the part of speech. So you can get a bunch of text in. So maybe I think the session before this, Niranjan was showing, you might actually process a bunch of customer comments, find the negative ones, and then use the syntax API to analyze those to find out specifically what was negative. Are they, customers unhappy with the price? Are they unhappy with the color? Are they unhappy with delivery, for example? So these APIs kind of work in conjunction sometimes. Awesome ringtone. Okay, so let's jump over. I'll kind of just give you a quick overview. We have a lot of content today, so I'll go rather quick through this. So one of the nice things that we did is we know that a lot. The displays are extended down here. Oh, sorry guys, 1 second here. Okay. Sorry, you're experiencing our last minute modification here we did to the speaker console. Okay. So one of the nice things we did is we know these services could feel complex at first. We know that, at least for me, I'll speak for myself, could be a little scary at first. Like machine learning is a really broad space. I don't really understand the concepts very well. I want to get started. So Amazon Comprehend, we did something kind of neat. We built a console which effectively gives you a WYSIWYG way to try out the service, right? So you can come into the console, and what you can do here is you can see that we have some sample text. So you can actually plug in anything you want. You can go to this console right now and just type in anything. And what you can do is you can hit the analyze, and then it actually takes that document, we call string of text, multiple sentences, we call it a document. It takes that document, it submits it against all of the APIs on your behalf. So then what you could do is you can go through the console, and then you can see, okay, it looks like here are the named entities that were extracted, right? So here you can see the names and then the category. We also return a confidence score. So the confidence score is our service telling you, this is our confidence that we're correct, right? So, when you think about these language services and these models, one thing is there's a performance in terms of, invoking the service and getting the response in the acceptable time. And then there's also quality of the results, right? So we'll tell you what our confidence score is. And this is largely good for if you want to set a really high threshold for confidence. So you might say something like, I'm going to throw out everything below 95. And if it's something where you're like kind of more doing research and you really don't mind if maybe the service is not getting a certain proper noun, then you could set it lower to maybe 90. So it's really nice. And then in this console, you can go through, you can see the key phrases we've returned. So these are common noun phrases. Over here, you can see the language is identified. And then, of course, you can see the sentiment. And then the last API is the syntax. So what I like to do also, what we did in the console, is not only do we show you the results of the syntax, but if you go way down here at the bottom, you can see the actual JSON response. So if you're kind of thinking about planning your application, and you're thinking about, okay, what does the response object look like? What does it contain? How am I going to wire it up to my app? We've made it really easy to kind of go through this console. This just gives you a sense to play with the service, play with the APIs. Okay, sorry guys, let me come back to the deck here. Okay, so one of the things, obviously being AWS, we're hyper responsive to customers. We care very deeply around their experience using the service. We celebrate their wins. We fix the issues. And we've been really fortunate to be able to work closely with Chick-fil-A, with Davis and his team. And we think they have a really compelling use case of how they're using Amazon Comprehend. So we just wanted to invite Davis up today to share with us a little bit about his experience. Thanks, Davis.
Thanks, Nino.
Thank you.
Appreciate it. Hey, everybody. So again, as Nino said, my name is Davis Addy. I'm the IT leader for food safety at Chick-fil-A. And I want to talk a little bit about one of the use cases we're doing with Comprehend in a really important area of our business, which is food safety. But a little bit of background around social media and its impact to food safety. So obviously social media is public, anytime there's a food safety incident that gets published on social media, it's usually widely consumed, viral in a sense. Because of that, information can be spread, it can be mismanaged, and other organizations or people could be looking at that and trying to make sense of, is this a true issue? Is this something that is a single instance at a particular restaurant or certain store or a certain location, or is this a trend of something bigger that's happening? So obviously being public, lots of eyeballs can see this information, digest it, and make sense of it. The other common area that we're looking at too, from a food safety standpoint, is because it's public, it's becoming a more common feedback platform. So how many in the room have left any sort of restaurant review on any platform in the last 12 months? So huge amount in the room. So customers are going to these platforms, they're leaving reviews, and so there's good information in there. Again, from a food safety standpoint, if there's a review that has a food safety mention, it maybe has a buzzword or something that's important that a company would want to know, that single data point by itself is relatively low just because it's one of many things that we can see. However, if you can mine that information and combine it with other food safety data sets, it can maybe start to tell a story or paint a picture of maybe what's happening at that restaurant. Is there truly a situation that's happening? Is there a trend that we can spot? And maybe then investigate and maybe stop something before it's going to happen at a restaurant. So for Chick-fil-A, and for one of the areas that our team was working on, we knew this information, there was some value in this information, but we really needed to mine it. Social media by itself is very noisy, right? So there's a lot of challenges when you look at social media data. You've got mixed tone, mixed sentiment, grammar issues, spelling, mixed construction, and really when it comes down to reliability, social media in its nature is subjective, right? And a lot of times there are unsubstantiated claims. So how do you make sense of all this? How could you actually use this unstructured data set and turn value into that? For us, that's where the need for natural language gene processing came in. And specifically for us, we wanted to find a solution, going back to what Nina was saying, an API would be great, right? That we could just call and leverage a service that could analyze data that we send to it and then try to derive value out of that. And ultimately, we wanted something that was going to be agile, scalable, cost-effective, and ultimately would improve over time with us having to do anything.
And then just one thing to, I think, double-click on too. Can you guys turn my, thank you. Is, this is the last bullet point Dave's mentioned, and the accuracy continuously improves. They're great customers. They've been using the service. There were a few sentiment things that we missed.
Yeah.
And this is, the experience was, they filed a ticket or, we're close relationships. They sent us an email. And the team got right on top of fixing it. So we had sort of identified the issue, we looked at the data set, we realized where our model was missing it and how we could fix it. And so I really loved that engagement because I think it showed that's actually the value of the service, is that we're sort of training it on your behalf and looking for ways to make the model better. So that was a nice one, I thought.
Yeah, absolutely. It's a great point, Nino. And for us, just obviously the use of the API and some of the benefits I'll get into, but that partnership as well, being able to give feedback to the product team and saying, hey, service is working great, but these are some things that we're seeing. Take a look. What do you guys think? So that's absolutely a valid point. So for us, what does it really look like to use Comprehend? So this is just a really high-level, simple kind of data flow, and I'll kind of just talk you through this a little bit. But essentially, at its core, we're ingesting data into S3. We massage that data. We check the sentiment, and then we do some sort of like a smart filter, a smart sort, where we take those results and really determine if it's truly a food safety issue or potential food safety issue from social media that we would want to investigate. And what's cool about this process is it's basically about 400 to 500 lines of code, and it's serverless, right? I don't have to spin up any EC2 instances to do this. It's a lot of API calls and essentially a Lambda to handle a lot of the data movement from bucket to bucket, and also the formatting of the data as we move from raw to filtered and enriched. And one of the key areas that I wanted to focus on here with this, before we get into calling the Comprehend API, is this idea, and I think this was mentioned in previous discussions already today about, when you're using Comprehend, if you're going to send it a huge block of text, it can be challenging, right? Because you might have mixed sentiment. You might have a lot of different things happening in that particular review. And looking, even just following the Comprehend documentation, Comprehend works best when it's targeting a specific sentence or phrase that you're trying to hit on. So for us, with the process, the way it works is we would ingest this data, all social media data from certain platforms, and we want to have certain buzzwords kind of trigger and pull that data out, right? So a lot of the fun words that I get to say at work that most people don't, so vomiting, diarrhea, sickness, throw up, right? So we have a kind of a data dictionary, if you will, of food safety buzzwords where if any of those words are mentioned in a particular review, we'll flag it, we'll pull it out and put it in another folder in that same bucket. And then from there, we'll extract out usually a sentence from that review or a certain phrase that we'll send to Comprehend, and we're really looking to see is that sentiment truly negative. Because some of the challenges that we saw specifically, and this is where NLP comes in very usefully, is you have a teenager that says, I love Chick-fil-A, they make a sick sandwich, right? So sick is that's one of our buzzwords. We're gonna flag that. We definitely don't wanna alert people at corporate or an operator because that's not necessarily a negative sentiment, right? So Comprehend can pick that up and say, oh no, this is actually a positive sentiment. This is just essentially a teenager using slang. So we deal with that all the time. So that's one of the cool things about Comprehend is it can catch some of that stuff. And really when it gets to that last bucket, that enriched bucket, that's ultimately where we sort all of the reviews that we think truly do have a food safety mention that we as a business would want to investigate further, right? And ultimately there's another Lambda that's gonna trigger a number of actions around alerts. We have an API that can expose this information. Of course, we use Athena as well to query it ad hoc at need. So again, it's a high level data flow, but what's really cool about this is the Comprehend section is about 4 lines of code, right? Most of the code in our Lambda there that's doing the work is just moving data around and formatting. So when we thought about, again, going back to how could we leverage NLP without us having to build it, because we're not NLP experts, right? That's not our competency. To be able to leverage this service and essentially just write a couple lines of code and call an API was perfect for exactly what we're doing. And then Comprehend in combination with a number of common AWS services really kind of completed our serverless solution.
Yeah, that's, I think a little bit to add to that point. And the flow is great because I think it's highly representative of this pattern. And, as you mentioned, most of our customers are general application developers, breadth developers. Maybe you're working on a relational database app before you took on the text analytics project. So, we were so excited, obviously, just to work with you, but their pattern is, and the amount of time and experience they put into building it, which is relatively short, really showcases, again, that value prop, and use it in conjunction with things like Lambda and Athena. It's pretty easy to stitch together these kinds of apps. So it's been great. Yeah,
absolutely. And then just to kind of wrap this up, really the key benefits for us were, like I mentioned, ease of use for the API, very easy to write this code into Lambda. The sentiment analysis was just specifically what we're using for Comprehend. And so, when I mentioned that we filter out certain words, if we just stopped at the filtering and didn't use Comprehend, we had about a 55% success rate of those reviews actually being something that we would want to investigate further. So that's not really good, right? Because if I'm building a service for the business or for our operators at our stores, and 45% of the time it was a false positive, they're really not going to see the credibility in this feature, right? They're going to begin to ignore it and not bother with it. And that's obviously, as an IT professional, it's not something I would want to do if I'm building a service for them. And so by using Comprehend, that actually increased our success rate by 30%, which is fantastic, right? And there's still areas that we can improve on with the team. And as Nino mentioned, the service is learning and getting better over time. And then the last piece, that's essentially the last bullet point, is the accuracy improves. So we're excited about this service. We're going to continue to use it, and looking forward to continuing to partner with the team to make it better.
It's been great.
Awesome.
Same on our side.
Thanks
for
Nino.
joining us today.
Appreciate
it. All right, so again, we're really proud of the partnership. We think they're building something really valuable, and more importantly, they're driving feedback that we're fixing. And I think lastly, we didn't say, he gave me a Chick-fil-A gift card today, so the whole thing is complete in my mind. So I will prioritize your stuff. I work for food. But yeah, thank you. Very proud of the partnership. All right, so at this point, we're going to get into the nitty gritty. We're going to roll up our sleeves, take a look at some of the solutions that we think are the most popular ones. Ben's going to walk you through code. The good news is most of these you can actually go find them on the blog, and if not, come up after and talk to me. And they're deployable formation templates. So most of the things you see here are either deployable today. You can go look at all the Lambda code, or we plan on publishing these within weeks. So the session will get pretty real here. Thanks, guys. All right, Ben, you want to head on up? Thanks.
All right. So in this next section, as Nino was mentioning, we're really going to dive nuts and bolts and show some of the systems working. We're really going to show a set of 3 demonstrations. And if I have time, we might sneak a 4th one in there that we may or may not have time for. The first one is, how many folks in the room use a relational database of some sort? Everyone pretty much raises their hand. At least if you're paying attention, you raise your hand. databases are used everywhere, right? Part of the challenge is a lot of times those databases store semi-structured text. You have these long text fields, and it would be really, really great to be able to take that data, run things like sentiment analysis on it, entity extraction on it, key phrases, syntax detection, and be able to really extract that and populate that as part of your data set in your database. And then really great, you could actually, once it's part of your database, you can start joining it with other data sets in your database, returning that data back out to your applications, that sort of thing. So that's the first flow we're going to be showing here. It's really, really easy to be able to set that up. There's a blog post today on how to do that. The other thing we're going to be showing, I actually listed them in kind of reverse order here. So the third one is what we were just talking about. We're also going to be showing how you could do content personalization. We're going to be showing how you could take data, ingest it through Comprehend using a serverless architecture, very similar to what Chick-fil-A does and showed on the screen here a moment ago, and take that and be able to populate things like a graph database, Neptune. And as soon as you have it in Neptune, you can do a whole bunch of different types of graph queries. So what are the most common nodes? What nodes are talking about the same thing? You know, the friend of a friend type queries, that sort of thing. So we're going to be showing that as a second example. And then lastly, we're going to show how you could take that information and really enrich your reverse indexing in something like Elasticsearch. And how can you couple natural language processing, add a semantic layer on top of your search capabilities, for example, using Amazon Elasticsearch. And then if we have time, we're going to show some social analytic queries, some dashboards there. So do you want me to talk to this, or you want to? OK.
So before Ben dives in, one of the things that we like to just, again, we love You Are Here maps, because we're going to show a bunch of concepts right now. So the real quick way to understand this, I think, is you got a bunch of unstructured text in the form of documents coming in, and we're writing them to S3. S3 is a great service. It's very inexpensive. It's really, truly amazing how many customer comments you can store in S3 for like $1. And then the idea is that everything will be around using Amazon Comprehend to build structure or extract metadata or data itself from the unstructured text. And then we're going to walk through a set of services that Bennett will build in conjunction with these solutions. And as you said, today we'll talk about RDS, Elasticsearch, and of course Neptune. So thanks, Ben.
Great. All right, let's go ahead and dive right in. So what we have running here is we already have a relational database stood up. I didn't want you guys to wait a few minutes as we stood up a Aura database or a relational database. But that's all we really set up. We haven't created any tables. We haven't created any procedures to actually invoke Lambda and anything like that. And we're going to actually do that as part of this exercise. So the first thing that we're going to do here is bring up a PHP MyAdmin page. And this is really just a web interface. And I'll make this bigger for folks in the back room. The lights are really bright, so you guys will really have to wave if you can't see. Because I can't really see the back of the room with those lights. But right now, we're connected into a relational database. So we have this Comprehend demo schema defined in it. It's a MySQL Aura database. And what we're going to do here is we're actually going to create a set of tables here. I'm going to save you guys from me trying to type create table statements and just paste them in. We haven't added the machine learning to fix me fat fingering these create statements. So we're actually going to do this, run these queries, and create these tables. And you're going to notice they actually, under here, if I refresh, oops. It actually just created these 3 tables. What these tables represent is this is some review data that we have in our relational database. It has review text. It has sentiment. We're actually going to have Comprehend populate that for us. This could actually be very, very rich. It could have all your other data in your ER diagram, in your relational database. But we have this table. We're going to insert into this table in a moment. But what we're going to do is we're also going to populate these other tables, this review entities and these review key phrase tables. And I'll show you the Lambda code that's doing this in a moment. But let's set up that trigger to have that Aura database call into the Lambda. And to do that, it's fairly simple to do. We're actually going to first create a trigger on that table. And I should mention, if you're doing a whole bunch of batch loading and you want to be able to highly optimize the batch orientation of loading a database for the first time, you may want to use something like Glue or another methodology to populate these fields. You may not want to use the trigger if you're actually hydrating a giant database the first time, but this is really, really great to keep things up to date and if you're not doing like that batch loading flow. But we're going to actually go ahead and create this trigger. And then this is actually where some of the magic happens now. That trigger calls a stored procedure. And this stored procedure here that we're going to create right now is actually what's going to call into Lambda. And it might be a little hard to see, trust me. This isn't smoke and mirrors. But this is actually doing a MySQL Lambda async call. Really, really great part about doing this as an async call here is under the covers, you could actually set up Lambda function level throttling to be able to limit how much requests get pushed back into your database at once. So you can set up that function level throttling, and since it's asynchronous, it will actually buffer those up to 6 hours as it's writing the data back out. That's one way to actually limit the connections and the write overhead of re-ingesting the data back into your database. This is just warning me because there's a drop in the beginning here. And so now we have the stored procedure here. What we're going to do now is we're going to insert some data into this database. And what I did is I actually grabbed some review data on echo dots. I love echo dots. I think I have about 11 echoes at my house. It's a real sickness I have. But we're actually going to ingest this review data. And one of the things you'll notice is we're ingesting an ID and a review text field. We're not ingesting sediment, entities, key phrases, any of that information, right? But what's happening is as soon as we did that call, that trigger is triggering, calling the stored procedure, calling the Lambda function we're going to look at in a moment to be able to glue those services together. And when I say glue in that context, it's not AWS Glue, but combine them together, and be able to then insert the data back into the database. So let's go ahead and take a look in the review data here. And if we look here, I wasn't fair to the Echo team. They always, if they sneak in the room and they always yell at me afterwards because there's much greater positive reviews than negative on the actual website. But I took half and half in this example. But here what you can see is sediment is actually filled in. That's actually filled in through that data flow that we're going to be showing in a moment. But what we could do here is we could actually start querying this data, right? We could look at the negative sediments and say, what are the entities being talked about? What are the key phrases being discussed for these different review information? I could also, if I have in my database like 1 star, 5 stars, I could actually correlate, is the text actually talking about in context of the star ratings? So I could start doing some analytics there. So here, you'll notice we just created this table. None of this is pre-staged, and all of this data just got inserted here. So you see the score that Nino was talking about earlier. I could have reduced, only ingested certain scores. You could also do that query time. But you see the scores. The other really important aspect about entities is you'll notice all the entities are typed. So it's really great to be able to ask for all the people entities, all the organization entities, all the dates, all the commercial items. So all these entities are typed, and those could actually become parts of your queries as you're analyzing and returning this data set back out. And as you expect, if we actually look in key phrases aren't typed, but they're really kind of these these phrases where a great item, an alarm, no reset, or no results, excuse me. So we're able to capture all this information and still have it in our relational database to be combined and used by the applications that are using that database. So let's go ahead and dive into what some of this code looks like. And this is one of my favorite parts because I really, I wish this was a lot of code, but I also don't because it's so easy to do. And if you actually look at the lines of code here in a moment, it's really only a few lines to code to be able to do that entire flow. So if we actually go into Lambda here, I have lots of Lambda functions. This is actually the Lambda function here. And I'm going to make this quite a bit bigger. I apologize if that's not. Anyone could like thumbs up, thumbs down? I could kind of. Is that OK? OK, mostly thumbs up, I think. OK. Throw something at me if you can't see it. If you could throw it, all the way to the stage. No. So this is the Lambda function here. What this is doing is it's actually being invoked by that stored procedure that we just looked at. It's passing in the ID and that review text. And then what we're doing is we're actually using in some environment variables to know the database information. You could use like secret stores, obviously, to store the database passwords, so all that's not in your code. Please never put your passwords in your code itself. And then what this is doing is literally this line of code here defines the SDK endpoint that I'm going to be calling. And then this line right here is all I had to do in order to pull out the sediment information. So very, very easy to take the data, call this, get the sediment out, and then here's just based on the ID reinserting it. So this entire function here is 26 lines of code. To be able to do this relatively easy, and then reinsert this data back into the Aurora database here. OK. Any last thoughts before I switch to? OK. So that's a little bit about how to integrate with your relational database. What we're going to show next here is how you could start using this in conjunction with graph data, knowledge graphs, that sort of thing. So what if you wanted to be able to create personalized content? If you know what content people are looking at, you know what entities and information about that content, and then you could then browse the graph, think of almost like friend of a friend, but do it based on your content to be able to suggest other types of content. So we're actually going to show a set of those next here. I'm not going to switch to the PowerPoint because it just has a title slide. So we're actually going to just dive into it. OK. So how many folks in the room are familiar with Neptune? OK. It's kind of hard to count with the lights, but I think it was maybe like 20 or 30 or so. So Neptune is our graph database. It's currently general availability. It supports both property graphs as well as semantic graphs, RDF. You could do Sparkle or Tinkerpop queries through Gremlin, that sort of thing. It's really, really great if you want to be able to traverse many relationships. Like, for example, a relational database is great if you aren't like doing tons and tons of joins together, right? As soon as you start doing all that, it starts, you don't have the same performance, that sort of thing. With graph databases, it's really, really powerful. It's meant to be able to do those heavily relational traversals of the nodes. Really great for things like personalized content. What we're going to be showing here is how you could actually set that up. And what I'm going to do first is I'm actually going to first show a terminal. I promise we won't stay in the terminal the whole time, but just for the Uber, I mean this in a good way, Uber geeks that really love terminals like myself, we're going to start here. And I'm running this on an EC2 instance right here, and we're actually going to connect into a Gremlin console. And the reason I like to show this is there's a lot of really great visualizations on top of graphs. But if you have an application that you also want to be able to expose graph-like queries to, you could do it through programmatic API type access as well. And what we're going to do here is I'm actually going to connect into my Neptune database, my graph database, just by defining a remote configuration and connecting into it. And the really cool thing here is through the entity extraction, what this data set represents is we've actually taken all the AWS blog data and ingest that and ran it through NLP, through Comprehend, and loaded this knowledge graph or this graph database within Neptune with that data. And we can start asking questions like, what are the most common entities being discussed? What authors are actually writing about the same content of other authors that are writing similar content to each other? So we can start asking all these questions that really fit very, very well into that graph traversal form. So the first query we're going to run here is really just doing a query to be able to identify how many degrees these various nodes have. And we're going to dive through this. I'm going to show you the actual node names and those sorts of things as well. Don't worry, you're not just going to see these vertex IDs the whole time. But it makes me feel better seeing these UUIDs sometimes. But here what we can see, though, is through some very simple graph queries. It's Tinkerpop, Sparkle, they're all open standards, even though we're using Neptune. So it's really, really easy to see these open standard query form paths to be able to process this knowledge that Comprehend has extracted out. So we see some nodes have very, very high degree, 100 to 75, 29, and then it starts dropping drastically. If I showed more than 10, you'd actually see the numbers drop very, very drastically. What that means is there's some core nodes that in this data set are all heavily connected, but then all these kind of spread out nodes from those core nodes. What we could also do is we could look at the eigenvector. It's really a measure of the influence of various nodes in the network. And again, this is actually all coming from entities pulled out through Comprehend. So through all these news articles or these blog posts, we could see what are the most influential nodes out of the entities that Comprehend extracted. AWS, Amazon, SageMaker, S3, EC2, DeepLens, Athena. So this is just one of the ways to start navigating this property graph. Just because visualizations are cool as well, let's actually show some of the ways of actually browsing that graph next. So I'm going to actually switch back over to my trusted browser. And we're going to bring up, this is an open source tool. We have a lot of really, really great partners that provide rich visualization layers on top of knowledge graphs and Neptune powered by Comprehend. And what we're going to do here is we're actually going to start browsing this knowledge graph. So we're actually going to first get the information out. We see at various locations, blog posts. Sorry, I try to be good about zooming in, but I'm not always, so feel free to do this, and I'll try to remember. So here we see the different node types. So let's go ahead and start navigating this graph. What if I cared about content related to, for example, MySQL? What I could do here is I could search my graph node for MySQL. These are the entities that Comprehend pulled out, and then I could see this MySQL node here. We could actually start showing the names. This is a MySQL node. I can move it around. It's really nice to be able to actually color code these so that different blog forums, so these are actually blog posts from different forums on AWS, and the color of the node now represents the different forums that are actually talking about MySQL. What we could do here is we could actually start navigating this now, right? So we could actually look, what other entities is this node talking about? I could start navigating down Kinesis and start looking at that. We could also show the weights. So that confidence score is always really, really important based on your business case. Sometimes you want to capture as much content as you can. What's the impact of like a false positive, low confidence score versus missing something? So these confidence scores are really, really good to be able to have in your application that Comprehend is just providing for us. It's really easy to integrate into our application. And you see that both in this knowledge graph as well as in those fields from the relational database. What we could show here, and this takes about a minute to load. And I didn't want you guys to have to wait a minute as I was loading all this data in here. But this is actually, if I didn't specify, this is the graph that is pulled out of here. And what we can see here is some very heavily connected nodes, just like when we're doing that Gremlin query. Some of those key nodes about Amazon, AWS are those nodes in the middle that are heavily connected. And then the sprawl effect that, as soon as you go a couple degrees out, it becomes less and less connected within here. Do you want anything? Okay, so let's switch to the last example, and we'll provide all the content. If you guys have questions after this, we'll definitely answer questions related to any of these as we have time at the end. But let's go ahead and dive into the Elasticsearch example. Searching been around a while. It's really, really great at reverse indexing and stemming, but it doesn't really have semantic. It doesn't have sentence structures. This is a noun. This is the verb. Those sorts of things. Also, things like entities and key phrases. Being able to use use those as a layer on top of your reverse indexing is really great to be able to do things like query boosting. Let's say you really care about person entities very greatly, so you want to actually not just search for a particular word, but when that word represented a person out of the entity extraction. So these are the types of things you could do once you start adding that semantic layer on top of the Elasticsearch. So enough of me. I promise that wasn't a stall tactic. But let's go ahead and dive into it. I like the music in the background. It gets me going up here on stage. So let's go ahead and dive into Elasticsearch. So we're going to go into this service. We're using Amazon Elasticsearch, fully managed Elasticsearch cluster. You can spin up highly available nodes, have multiple masters, all that good jazz. I'm sure there's teams talking about Elasticsearch sessions just in depth. What we want to show in this context is how you could start using that NLP information, those entities, those key phrases, those sediments, to be able to really boost that query performance and also build various visualizations with that data. So I'm actually going to go into this cluster here and bring up a Kibana front end. So Kibana is a web interface used a lot of times in what's called the Elk stack, Elasticsearch, Logstash, and Kibana. And what we're doing here is we're actually hitting the Kibana instance that's running on the Elasticsearch cluster, the Amazon Elasticsearch cluster. What we could do here, though, is we could actually start looking at this data. Oh, sorry, nobody threw anything at me, but I forgot to make this bigger. You guys were being too polite. So what we see here are these articles, the same sort of articles that we were using in the previous example, but now we're doing more of a search and semantic layer on top of it. And what we have here is the various articles indexed. And if we look down over on the left-hand side, we actually see the various fields, but we also see these comprehend fields that have been added. So just like what Chick-fil-A was showing, just like in the other example of the Lambda invoking the comprehend, this is all being done through a serverless pipeline. So we're actually using a service to pull all these logs out. We're actually running it through Lambda, running comprehend to enrich the data, using Firehose to write the data into Elasticsearch for us. And all that is very, very streamlined in terms of that processing flow. What we're going to do here is we're actually going to start showing how you can start searching for this now. So if I actually search for Lambda, I see 52 hits out of this data set. And you'll notice a lot of these hits have to do with various portions of the data. It might be the title. It might be part of a URL that has Lambda in the name. It's really hitting any portion of this content when I'm doing this search. What's really great is since that entity information and the key phrases and all that information is in here as well, I can actually start searching the entities rather than just the raw content. So here this is searching for Lambda within the entity extraction portion from comprehend. And what I could start doing here is if I actually look inside here and look at this document, we can actually see all these entities that have been pulled out of the extraction phase within this data flow. I could easily have added some of the other query parameters here where I actually specified the entities.type as organization or those sorts of things as well. So this all becomes part of that searchable content within the in the store. So what we can also see here is as we go down here, we see all the various phrases that are within that particular document. Document in this context because Elasticsearch calls things documents as they're indexing them. They're really these blog posts. What we could then start doing is we could actually start visualizing this data. So what if I wanted to actually create a new visualization? And let's actually just create a simple pie chart at first. And what I could do here is I could very easily start going in here and do things like I want to actually see this, and I want to select maybe the entities field here. So down here, I could actually select the entities. Maybe I want to see based on type. If I look at this here now, I see all the different types, right? So I see the organizations, I see the commercial items, that sort of thing. very easily I could then add like another layer on top of my pie chart. And let's add another layer here. I have some pre-baked visualizations and dashboards we'll show in a moment. But here, if we actually want to see like a subcategory after we see the types, if we actually want to look at the actual text itself of what the entity was, we could do that as well. So now we see within commercial item, there's another layer on top of that listing all the commercial items that Comprehend found, and I could very easily query within this Elasticsearch cluster. So here we see commercial items. Over here I can see EC2. I can see RDS, that sort of thing. From visualizations, we can actually start building dashboards on all this data as well. So this is the dashboard showing that pie chart that we were just showing a second ago on the left-hand side. But on the right-hand side, we actually did a tag cloud or a word cloud. And what we did here is rather than using every piece of text that it showed up in all those blog posts, we actually used the NLP from Comprehend to be able to pull out key phrases first. And now we're plotting the data of the key phrases rather than just all the data that we may have to be able to really help improve the relevance, the information displayed on that word cloud. Okay. Do you want me to show the social media? Do you think we have time? OK. OK. So that was a little bit about the Elasticsearch integration and how you can start bringing that in. For the last demonstration, we actually wanted to show a social media example. So in this example, we're actually showing the ingestion of tweets, being able to run sentiment analysis, entity extraction. It's also running Amazon Translate, so we're actually capturing tweets on 6 different languages. We recently announced 6 more that Translate supports to be able to not only capture these tweets, but also transform them in different languages to be able to then build some dashboards on. So over here, I'm going to bring up the console again. I'm going to jump into QuickSight. QuickSight is an AWS product. It's a BI product that we have to be able to have a cloud-based product that very easily integrates with a lot of our data services as well as external services. We have adapters to Salesforce, ServiceNow, a lot of those sorts of things. But what we are seeing here is we actually have this dashboard that we built. And this is showing the sentiment of Twitter, of these tweets coming through. And as soon as the tweet comes in, we first check the language. Twitter actually has a language field, but if we didn't have that, we could very easily have called Comprehend and did detect language, where we support 100 different languages in detect language. Some very, very high number of languages supported it in detect languages. It's really quite amazing. But we didn't have to do that because the tweet had the language already in it. And then we run it through natural language, Translate, and then we do this sentiment, entity extraction, that sort of thing on it. So over here, we actually see all the various tweets with the sentiment. Obviously, during re:Invent, we actually have a lot of Twitter activity during re:Invent conferences to be able to have that shown here as well. And that's what represents this big spike here. What's really interesting is this entire pipeline we set up before re:Invent, November, maybe a month before that. And we haven't touched this pipeline since. And it's still running to be able to start ingesting this data. So I actually have this scroll to the right. But as I scroll over here, you can actually see this is actually still running. And since it's done in that serverless architecture, it's very, very low maintenance for us. This is done in our accounts. These are demos we give as essays, that sort of thing. So it's super hands-off when it comes to this architecture to be able to elastically scale as the tweets come in. When tweets come in at higher rates, Firehose automatically handles that. It writes it to S3, the Lambda invocation. Everything is scaling very, very seamlessly to be able to absorb that load and only pay for those costs as the data is coming in. So it's very, very one-to-one driven based on the actual usage, the actual need there. So we currently have this filtered by commercial items. That's why there's less tweets over here. I could actually go in here and remove the filters. And you actually will see much greater numbers up at the top and that sort of thing. But here we actually see the various entity types, the geolocations of where the tweets are happening, the various entities pulled out. And then down here at this lower level, we actually see the machine translation from Spanish, French, German, Arabic, Chinese, all the different languages we're doing translation from. Oh, sorry, I hit the back button. All in that one dashboard showing the sediment over time there. So unfortunately, I could talk about this for about 2 days, but I have 2 more seconds. So from there, I think we're going to switch back to Nino.
I think one of the coolest things is, like I mentioned, you can go to the AWS ML blog, search for Ben's name, and you can download this entire thing and deploy it as a formation template. Go to Twitter, just get your own dev key, put in the actual Twitter handles or tags or even words that you want to track, and you could have that whole thing up and running. I actually timed myself. I did it in like 24 minutes. And I didn't write any code. I just got my own dev key and put it in my own terms. So it's kind of cool. So at this point, I think, Dave, you want to come back up? And Ben, you want to come back up? We'll do like a little Q&A. But again, we're really excited about how easy we're making this. We want you guys to kind of go check out these demos that we put online. Can I do a quick question before everybody takes off? How many folks in the room would say that they're in, maybe the insurance vertical? Okay, how about healthcare? Okay, interesting. How about things like popular media, news, publishers, things like that? How about legal? Okay, media and entertainment? Okay, very cool. All right, just really interesting. Comprehend itself has been trained across a number of verticals. It's highly accurate in a number of different ways, but we just kind of like to pay attention to that signal. So we'll open it up to Q&A. So if you guys have any questions. Otherwise, everyone else is free to leave. Thank you very much. Thanks. Right there, too, if you want to do a question. Oh, yeah, go ahead.
Are there different, response versions trained on different corpuses of data? I know we've had issues with image recognition being trained so generally, it just represents a lot of things, hyper-specific. So you're talking about legal. Is it trained? Is there a specific API that is trained just on legal?
Yeah, great question. So the question was, does Comprehend offer different APIs for different verticals of data, so legal, health, or things like that? Today, it's a single API. We do train it over. We ourselves collect data from all these different verticals. Just because we build a sentiment API, we want to test it on a different vertical. We look for entity extraction in legal versus retail. So we do that ourselves. So today, it's a single API. Yeah. Yep. So great question. So the question is, do you have something for finance? And I'll expound on that a little bit. We hear a lot of our finance customers say things like taking a dive. That's obviously a negative connotation, things like that. So today, the service, again, is still generic. We do have finance customers using it. We have a number of finance customers and insurance customers doing financial analysis on it. So I urge you to try it out. But specifically adding things like deep financial terms, understanding context of a transaction are not things we support today. But I think if I could bump it back up, we are taking all this feedback, and I think it's fair to say the team is actively working on ways that we can make the service more targeted at specific verticals for really specific text analytics use cases. So today I'd say it's more of a general trained service across these corpuses. Great question. So let me repeat it. His question was, I assume you have dictionaries that are looking for entities. Number one is we actually don't have dictionaries. These are neural models. So we're not doing string matching. The question was, if I don't see the entity I want extracted, can I add it later? So today it's fixed. That being said, we don't generally do timelines, but I can tell you from a product roadmap perspective, we do want to support that scenario. We think it's obvious. one business might have an alphanumeric code that's a key product ID. Another business might really specifically be looking for a certain phrase. So we'll have that coming. That said, the syntax API does parse it down to word boundaries. And today you could effectively write really small regex tokens that have your own thing. So you can do this today. But we're going to make that very easy in the future. Yeah. Thank you.
So questions for Davis.
Yes.
So two questions for you. One, since data is cheap, are you doing competitor analysis and thinking about what's happening with Chipotle right now? And the second thing is, when it comes to food safety, a lot of it has to do with employee handling, and that actually came up in the keynote this morning, like people would leave freezers and refrigerator doors open and it would
Yeah.
become potentially compromised. So are you using any of the data for employee performance?
Sure. So the first question is, were we using a similar pattern for competitors? We are not. Our core focus is our own restaurants. We have 2,300 and trying to expand. But there are other organizations out there that, I mean, it's public information. So in theory, anybody in this room could take what I showed on the screen and hit all the major players up and start looking at their data. But for us, obviously, we're just focused on Chick-fil-A and making sure our restaurants are safe. The second question was around food safety. Yes, the employee piece, the team member piece is important. In terms of what I shared in my presentation earlier, we have phrases and things that we're looking for. So if there's definitely things in the comments and the reviews that mention a team member, maybe how they're handling food, or they see something that's improper, those definitely get identified just as much as someone saying, I got food poisoning. And so, again, where we identify that information and we can spot that as a trend, especially with maybe some internal data as well, that's something that we can highlight specifically with that restaurant and maybe targeted certain training, or maybe it's a team member issue. And so we're on a journey. We're just kind of getting into this to see how this data can be valuable, but we are seeing some early promise with it. But that's definitely one of the areas in terms of team member and changing behavior if we're seeing social data reflect that.
Sir? Great question. So the question was, how do I go get all this data? There's maybe like a blog I want to go look at and scrape, or forums. The short answer, it's kind of a variety of tools. I know there's a lot of really nice open source tools around doing web crawling, scraping. There are a lot of public data sets that are available. AWS has some, the other cloud platforms have some. But if you're really like, hey, I want to go get data from a specific blog, I would look at writing maybe a script or something that can ingest all the RSS feeds and then write them into S3, right? I'm sure, Ben, you probably have like a ton of tricks too. But yeah, it's really kind of a combination of scraping versus subscribing to feed sources and ingesting it yourself. Yeah. Yeah.
Where you have resumes.
Yeah.
If you have to break that, what's your experience on performance side to get better results?
So yeah, so you're using performance and the accuracy perspective. Okay, great. So the question was, how do we increase the performance of the accuracy for sentiment? And so today, the way the service works is you could feed it like a 4-paragraph document, and we'll return back to you sentiment. Obviously, we all in the room know that over 4 paragraphs, the chances of sentiment being mixed are pretty high, right? The 4 paragraphs are probably saying negative and positive things. So our suggestion is that you can actually truncate all the way down to a sentence. You can actually go inside of a sentence. I think, for example, like I love my Nikes is something that will represent and is positive, right? So we actually have a trained classifier. So our feedback is to go down to the sentence. But you can actually go smaller than that, right? So what you could do is you could use the syntax API, break the text up. The syntax API gives you offsets, so you can say, okay, look, this is really interesting. I see a bunch of descriptive words here, and then you can train the ingestion workflow to actually go truncate that specific sentence around that offset. So I've seen that as a trick that works. But right now, our formal guidance is just go through user standard library to do truncation at the sentence. And then from there, then maybe you want to use syntax on the sentences to really understand what's going on. Niranjan actually built the previous talk. He built a demo. If you stick around, I can give it to you. Maybe I can even just give you the code, just make it easy. But that would be our guidance today. We are thinking about making that easier for you in the future. I don't expect you to keep saying that. Okay, one more. 26 seconds. Great question. So the question is it absolute negative? So what we do is we have a trained classifier that classified to do sentiment analysis. And what it'll do is it will tell you what it is, the overall confidence of which either positive, negative, mixed, or neutral. So we don't say it's absolutely just 70% positive, take that, but it'll actually break it down to you across those 4 classes. So think of those as 4 classes, and then what a lot of our customers do is they'll say, look, I'm gonna set a threshold. If it's over 75% positive, I just know it's positive, right? But I urge you, take a stab, go look at the data, but you'll notice it's pretty, it definitely has a confidence that will push it in the right direction. But we do break it down across those 4 classes. All right, okay, so we're out of time. I'm happy to stick around. I'll go hang out over there. Thanks, guys. Davis, thanks again.
Thank you.
Chick-fil-A. Thanks, Ben. Amazing.